Here we're asked to find the solutions to a system of equations algebraically, and we're given an equation of a line and an equation of a parabola. Since they're both set equal to y, we can substitute and combine them together because if this equals y and this equals y, they must equal each other. Before we can solve for x, we need to have this entire quadratic equation over on one side and have it set equal to 0. Now, any quadratic equation you can solve using the quadratic formula, but often people first look at it and see if you can solve it by factoring, which is often a little easier, less room for error. So let's take a look, and I notice that each of these terms I can divide by 4. So first I'm going to factor out this greatest common factor. Now what's left inside the parentheses has 1 as the coefficient in front of the x squared. So that means we're looking for two numbers that multiply to give us the last number and add to give us the middle number. And if you go through the different options, you'll see those two numbers are -3 and 1. So that means inside the parentheses, when we break this up into a multiplication problem, you have your x and then your -3 and +1. At this point, now that we factored it, we can use the zero product property to solve. Now remember, if you have numbers that multiply together and give you 0, then 1 or all of these numbers must be 0, because anything multiplied by 0 is 0. So we know 4 isn't 0. But since we don't know what x is, we don't know, maybe x minus 3 is 0. Or maybe x plus 1 equals 0. So what you do is you solve each of these little equations to see what values for x will give you 0 for this equation. And then once you have those, we can figure out what y is. Now, we have two values for x. That is not saying that our answer is this. That isn't the point where these two lines intersect. That is telling us that the 2 points where they intersect have x values of 3 and -1. So we need to see what is y when x is 3 and when x is -1. Now what you do is you look back to our original equations. You can pick either one of those equations, whichever looks easiest. I'm going to pick the first one, and I'm going to substitute in each of these x's and solve for y. And in doing that, I found that when x is 3, y is 11. When x is -1, y is -1. So those are the 2 points. If you were to graph these two equations, those are the 2 points where they will intersect. Those are the solutions to this system of equations.